Our job is to differentiate y with respect to x, and therefore we're trying to find dy by dx. In this case, we can't just see it as a polynomial unless we expand x squared plus 14x plus 49. And then we could go ahead and differentiate. We could say 2x plus 14. So we'll bear that in mind. But if we're going to do this using the chain rule, first of all, we're going to decide that there's a function inside a function here. And we could see x squared is a function that we might be plotting, y equals x squared. We could also see we've got a linear function there that could be x plus 7. You imagine that you replace that x with the x plus 7, and that's what you have there. Combination of 2. So in order to find the derivative here, we're going to do the chain rule. We're going to use a particular methodology here, which could call it the box method, the cross method. But if we keep some sort of regularity, it might help us to at least begin a question, get going with it. It all starts in the same way. So in this case, we've got the function inside here, which is u, and this will go on the left. And then overall, we have a function that is y. And because we defined that bit as u, it's now u squared. And since we intend to differentiate this, we fill out the bottom as du dx, which, as we can see here, the 7 goes, we're just left with 1. And here we have dy by du, which is 2u. And with this method, with the chain, perhaps we could write chain. We're going to multiply the 2 at the bottom. The way this works, we're going to have du by dx multiplying by dy by du. As you can see, the du's are going to cancel. We end up with dy by dx, which was what we wanted, and it's going to be 1 multiplied by 2u. Now I'll go to the next stage. Dy by dx is equal to 2 lots of u, and up there, that's x plus 7. Okay, so we found the derivative. Now, bearing in mind that we have this box method here, and it's going to be very similar for a lot of them. If you like this and you understood it, click on this video here and it will tell you about the next in the series that uses the same methodology that will help us be more confident in the exam.